geometry to another section. This time we're going to talk about using similarity to find sides on some what we're going to call special right triangles. So when I say that this relies on our similarity, we're going to be using the scale factors and proportions of specific triangles that have certain angles to find the measures on any other triangle that happens to have those same angles. So remember, when figures have the same angles, then they also have proportional sides. So the first of these triangles is what we're going to call the 45, 45, 90 triangle, or the isosceles right triangle. So isosceles right. Okay, so the 45, 45 is called this because it's a right triangle, and the legs are the same size, and the angles are 45 degrees. Remember, all it takes to know that two triangles are similar to each other is to know two of the angles are congruent. So if we have another 45 angle here and a 90-degree angle here, we know this is a 45, 45, 90 triangle. It's going to be similar to every other 45, 45, 90 triangle. So what we're going to create here is what we're going to call a reference triangle. It's a triangle that we can reference to set up a proportion for our similar figures. So the two legs are the same size. So since in proportions and scale factors you can always reduce ratios, we're just going to call these 1. Okay? So if this leg is 1, this leg is also 1. And we can use the Pythagorean theorem to find out that this hypotenuse here is the square root of 2. Right? If we said 1 squared plus 1 squared equals c squared, we'd have 1 squared is just 1, 1 squared is just 1, 1 plus 1 is 2, and then square root is root 2. So this reference triangle, 1, 1, and root 2, which means that we can use this reference triangle to set up a proportion for a problem like this. If we know that this leg is 10, well, the legs are the same size, so this leg is also 10, x is 10. And this y here is, if it's root 2, we can say, all right, 10 to 1 is the same as y over root 2, y over root 2. Multiply the cross products. Y times 1 is just y, and 10 times root 2 doesn't simplify any further. It's just 10 root 2. So this is 10 root 2. Okay, so since this is a 45, 45, 90 triangle, it's similar to our reference 45, 45, 90 triangle, and we can use that to set up a proportion. Now, once you get comfortable enough with it, you're going to start to notice that this hypotenuse is always simply the leg times root 2. The leg times root 2. So what sometimes people will write is a reference triangle as instead x for the legs, and then the hypotenuse is x root 2. So whatever the leg is, the hypotenuse is just root 2 times that. And then if you have the hypotenuse and you're going backwards, we can divide by root 2 to find the leg. Okay. So let's look at one more 45, 45, 90 triangle. Our next couple ones here, notice, or this next one here, notice x and y. Well, they're labeled differently. Notice the dash marks on the sides, which means that these legs are the same length. This is an isosceles right triangle. It's going to be a 45, 45, 90. And if our hypotenuse here is 6 root 2, we can say, all right, using our reference triangle, 6 root 2 over root 2 is equal to, so 6 root 2 over root 2 is equal to, let's do x over 1. Okay, and then use the cross product. And actually, this is going to simplify. We don't even have to do the cross product. 6 root 2 over 2, root 2 divided by root 2 is 1, and we just have x equals 6. So x is 6, and then y and x, the legs are the same size on 45, 45, 90 triangles, so y is also 6. Okay? one more 45, 45, 90. Actually, we'll come back and do this at the end. We're going to do, let's switch to our other special right triangle, and we'll do those last two examples. So the 30, 60, 90 triangle. This one is comes from equilateral triangles. In an equilateral triangle, all the angles are 60. Right? All the angles are 60. And our motivation behind this 30, 60, 90 triangle is if we have an equilateral triangle, sometimes we'll want to know the height if we're trying to find the area. And so if we draw the altitude or the height in here, it splits that 60-degree angle at the top into two 30s. So we get a 30, a 60, and a 90. Now, for our reference triangle, we're actually going to ignore that half of it. Okay, so we're just going to look at the 30, 60, 90. I'm going to leave kind of a dotted line version of that just to show where this came from. Now, for this 30, 60, 90 triangle, I'm going to actually call this side length, that was the side length on this equilateral triangle, I'm going to say that it's 2, and you'll see why I'm going to do that in just a second. When I draw the height in this equilateral triangle, that other side there gets split in half. And so what was 2 units long, half of that is 1 unit long. Okay? So that gives us a nice ratio to work with. This leg is half as long as this, but instead of saying this is 1 and this is 1/2, it's going to be easier numbers to work with if we call this one 1 and this one 2. Since we're just looking for a reference triangle that we can simplify the ratios for. We can find the height using the Pythagorean theorem. So if this is b, then b squared plus 1 squared equals 2 squared. And 1 squared is just 1, 2 squared is 4. And we can subtract to find that b squared is 3. And then the square root, both of those, so our b is the square root of 3. So this other leg here on that triangle, the height of our equilateral triangle, is the square root of 3. So for our reference triangle, we have 1 for our short leg, root 3 for our long leg, and 2 for our hypotenuse. Okay, so 1, root 3, and 2. So when we talk about the ratios of the sides, when I want to find the missing sides here, the 4, the side across from the 30-degree angle, is the short leg. So this is our short leg. And our long leg is the root 3, and our hypotenuse is the 2. So on here, side across from the 30-degree angle, across from the smallest angle is the smallest side, that's our short leg. So when I set up my proportion, and I want to find x, I can say, all right, 4 over 1 equals x over 2. My hypotenuse goes with the 2. And then when I do the cross product, 1 times x is x, and 2 times 4 is 8. And what we're going to find is that the hypotenuse is always twice as big as the short leg. Twice as big as the short leg. So another way to draw this reference triangle, kind of like we had this one in terms of x, we had x, x, and root 2. We can have, in this reference triangle, our short leg is x, our hypotenuse is 2 times x, and then our longer leg is going to be root 3 times x, or x root 3. X root 3, just like we had the root 2 times x is x root 2. So x, x root 3, and 2x. So when I want to find y, we could set up a proportion, 4 over 1 equals y over root 3. And then use the cross products. 1 times y is y, and 4 times root 3 is 4 root 3. Now, once you kind of get comfortable with the idea that this longer leg is always root 3 times whatever that short leg is, we can just simply take 4 times root 3 to get 4 root 3. Okay, so looking at our next one here, there's our 30, there's our 60. The x, that's our short leg. The 9, that's our long leg. And the y, that's our hypotenuse. So remember since everything's kind of based around that short leg, it's usually a good idea to find that short leg first. So if I'm going to compare 9 to root 3, long leg, is equal to x over 1. And then in this case, well, x over 1 is just x. So this is 9 over root 3. But that's not simplified. We have to simplify this further by multiplying by root 3 on top and bottom to get 9 root 3 over 3. And then 9 over 3 is just 3. So 3 root 3. So our short leg is 3 root 3. And remember, the hypotenuse is going to always just be double whatever the short leg is. So we could take a little bit of a shortcut here and say that y is just 2x. So it's 2 times 3 root 3. And when we multiply, we can multiply the stuff that's outside the square root together. 2 times 3 is 6. So we have 6 root 3. Okay, 6 root 3. So for our last two examples here, let's revisit this. Let's sum up. It's usually a good idea to draw a reference triangle for the triangle we have, just to have something to compare to. For our 45-90 triangle, it's a 1, 1, and a root 2. So if this is 13, that's going to go with the root 2, right? So 13 over root 2 equals, and I'm going to say that this is my x that I'm trying to find, the missing side. So if it's 13 over root 2, that's going to equal x over 1, x over 1. In fact, x over 1 is just x, so I just actually have to divide 13 by root 2. 13 divided by root 2. We have to multiply by root 2 on top and bottom. So 13 root 2 divided by root 2 times root 2 is 2. And 13 isn't even, so that is as simple as that one can get. So 13 root 2 over 2 is how big both legs are. Both legs are 13 root 2 over 2. And if we multiply by root 2 to get that hypotenuse, root 2 times root 2 is just 2, and the 2's will cancel to get 13. So we could check our answer that way. And then our last one here, we have a 6, an x, and a y. So using a reference triangle, short leg is 1, the long leg is root 3, and the hypotenuse is 2. Remember, hypotenuse is twice as long as the short leg. So if the hypotenuse is 6, we could say that x is just 6 divided by 2, which is 3. And then the hypotenuse, or sorry, the longer leg is root 3 times the short leg, so the hypotenuse is just 3 root 3. So once we kind of get the hang of this longer leg is always just root 3 times that short leg, we can just multiply by root 3 to get the long leg, or divide by 2 to get the hypotenuse, or to get the short leg from the hypotenuse. So there's our x, there's our y. Now you can set up the proportion each time if you want, but finding how the sides relate to each other is the quicker and easier way to go. If you don't know the short leg, that's our first step. Always find that short leg. So in this one, you had the long leg, divide by root 3. All we had to do is divide by root 3, and then multiply on top and bottom by that square root of 3 to get our short leg. and then double it to get our hypotenuse. So the hypotenuse is always twice the short leg. Long leg is root 3 times the short leg. Okay. Let me know if you have any questions. We'll have some practice with that in class. See you then.